Hey everyone, what's going on? This is William. Today I want to start talking about recursion, a concept that I frequently use in the videos I make but haven't really done a deep dive on. So today I want to begin introducing recursive functions and some of the core concepts you need to know to get started with recursive programming. So without further ado, what the heck is a recursive function? It's a function that calls itself to solve a problem. It does so by breaking down a problem into smaller, more manageable subproblems. Recursive functions are particularly useful in situations where the problem can be represented in a tree-like structure, such as traversing a directory or searching a graph. You'll also encounter recursion when trying to implement mathematical functions or solving dynamic programming problems. They're also very useful when trying to brute force combinatorial problems or searching through a solution space. It's certainly a very daunting topic and there's a lot to cover, but I think one of the best ways to learn recursive programming is by looking at lots of examples, and that's primarily what we're going to be doing. So to get started, I want to begin by taking a look at a simple function. The function below is a recursive function that sums up all the numbers from 1 to n for some value of n. For example, sum with n equals 3 returns a value of 6, since 1 plus 2 plus 3 equals 6. Similarly, sum with a value of 5 would return a value of 15, since 1 plus 2 plus 3 plus 4 plus 5 is 15. I think you get the idea. A recursive function can be broken down into a few different components. The first component is the base case of the function, which serves as the terminating condition for the recursion. All recursive functions have base cases, whether the base case is explicit or implicit. The way the sum function works is by taking the value of n and working down to 1, summing the total backwards, if you will. This means that the value of n will eventually get reduced to 0, at which point the recursion should end. In the example below, boxed in red is the base case for the recursion, which checks if n equals 0, and if so, returns 0. This causes the function to return and for the recursion to begin unwinding. We'll get more into that soon. The next component of a recursive function is the recursive call within the function. This is where you typically transition to a smaller subproblem that gets you closer to the base case. Below you can see that sum gets called recursively but with a parameter of n minus 1. This says sum all the numbers from 1 to n minus 1. I want to emphasize that it's crucial for the transition to reduce the value of n and bring us closer to the base case. If the value of n were to stay the same, we would get stuck in a loop and never be able to exit the recursion, likely causing a Stack Overflow error because the function would keep calling itself with the same parameter. The last component of the recursion is the body of the function, or the work being done in the function. In this case, the body of the function is adding on the current value of n to the sum. While the work of this function is only an addition, in general, it can be much more involved. Okay, now let's walk through in detail how the sum function works, since this might be your first time seeing a recursive function. Let's suppose we want to sum up all the numbers from 1 to 3. Then we would call sum with a value of n equals 3 as our original function call. On the right, I'm going to display the stack frames of the recursion, or the sequence of function calls used in the recursion. The first function call is sum with a value of 3. When we enter the function for the first time, we check if the value of n is less than or equal to 0. And since it's not, we recursively call the function with a value of 2 and add 3 to the sum. In the next call, now the value of n is 2, so we check if n is less than or equal to 0. It's not, so we recursively call the function with a value of 1 and add 2 to the sum. Then we do the same thing again, check if n equals 1 is less than or equal to 0, and recursively call the function with a value of 0 and add 1 to the sum. Now the value of n equals 0 and something interesting happens. We return a value of 0, which ends the recursion and causes the stack to unwind. The stack is the column of function calls on the right. Since each function call we are adding n to the sum as we return up the stack, the results of each function call get added up together into a final sum. Observe as we unwind or go back up the stack. First we would add 0 plus 1, then 2 plus 1, and then 3 plus 3, and then all those get added up and we have our final answer of 6. So in summary, a recursive function is a function that breaks down a problem into smaller subproblems which are easier to solve. In the example we looked at, the sum function recursively called itself to find the sum of all the numbers from 1 to n inclusive. Then we looked at 3 of the main components of a recursive function. First was the base case of the function, which serves as the terminating condition for the recursion. Next was the function call within the function, which guides the recursion towards the base case. And finally, the body of the function, where the actual work of the recursive function gets done. Alright guys, that's all I got for now. Thank you for watching. I hope you learned something, and I will catch you in the next one. See you later.